I was meant to make a video on quantum wave functions, but I'm sick, which is also the reason why I'm wearing sunglasses. My eyes just don't look as beautiful as they usually do, and it was really tarnishing the quality of my videos. That being said, I do need to upload something, so I thought, why not, let's just do some simple mathematics.
30 seconds.
Off the bat, there's just too much going on, so let's just focus on that central expression there. Notice that a lot of them are just the sines of angles and the sines of the doubles of those angles. For example, sine 6x is just sine 2 times 3x. So we bring in our trusty old friend, the double angle identity for the sine function. It's of course 2 sine x times cos x. And when we implement that across the whole fraction, we can boil it down to just a bunch of cosine functions because all the 2's and the sines conveniently cancel each other out. With this, and now you notice that this is just the cosines of the triples of the other angles, so we just bring in our triple angle identity for the cosine function. Now, if you're coercive or toxic to your relationship partner, you're very familiar with this next step. Manipulation, specifically algebraic manipulation, because we're going to sub out the cosine function and do this for both fractions. Conveniently, you'll notice that the cosine x and the cosine 5x cancel each other out. We're now left with 4 cosine squared 5x minus 3 all over 4 cosine squared x minus 3. We can write that minus 3 as minus 1 minus 2. Now, do you notice something interesting about the circled term? Of course you do. It's just one of the 3 iterations for the cosine double angle formula. It means this entire beast of an expression can just be written as this. But we're not done simplifying yet, because we need to make things a bit more imaginative. That pun makes sense because we're going to be using complex analysis. The function of cosine theta can just be written as e to the I theta plus e to the negative I theta all over 2. And we're going to utilize this a lot throughout the whole integral. After pushing this into our original expression, we're left with this. E to the 10ix plus e to the negative 10ix minus 1 over e to the 2ix plus e to the negative 2ix minus 1. I'm not done manipulating yet. Oh no, you toxic kings and queens. Because now what we're going to do is sub out the least term. Here is where things start to get spicy. We want to make things a little easier for ourselves. So we're going to let e to the ix equal t. Henceforth, we can write our original expression in this format. Here, I guess we've tidied things up a bit, but the term on the right still looks like a headache. Fortunately for us, we're tough mathematicians, so we're just going to brute force our way through it with some long division. That's the full method there. Pretty standard GCSE further math stuff. After we're done with that, we're just left with 1 over t to the 8 times this hella long expression. After we're done with that, we're left with this. But remember, these t's are just the function e to the ix in disguise. And when we sub that in, gasp! It's just a bunch of cosine functions. Nice, lovely jubbly. We just end up with a bunch of cosines. But wait! Remember, the original function we need to integrate is squared, which means we have to square this whole thing first. So we just have to integrate this, right? Wrong. We're going to split up our integral into 3 separate integrals. The square terms, the cross terms, and the teensy little one at the very end. Cool, so let's start with the biggest first, because that's the one we need to get out of the way quickly. Take the integral of any of these cross terms consisting of the cosine function, you get the function sine of some constant multiplied by x. Now remember, the integral is between pi and 0, and when we look at the graph of sine x, we find that it's 0 at pi and 0. So it's safe to say that this whole thing is just 0. Next, we move on to the square terms. Now remember, we can write cosine squared of x as this through its double angle identity. So we're going to do that for all the cosine functions. We end up with this. Now, since we already know that the cosine functions will integrate into sine that we've already established will end up as 0, we don't need to worry about those. We just need to worry about the 2's that we have here. So what we're going to do is just get rid of all the cosines. We're just left with 3 2's. So our integral for this is just 3 times 2 pi, which is 6 pi. Which means this whole thing here is just 6 pi. And we're just left with the integral of 1 between pi and 0 with respect to x, which is like the easiest thing ever. That's just pi. So we just add those two together and we end up getting 7 pi. Yes, folks, that is the correct answer. And we just did it I think we're just qualified to be MIT students now. Shout out to, of course, the greatest of all time, Massachusetts Institute of Technology. They're just like, I love them so much. Their professors, their students, just everything about them. And putting this challenge on every year. This problem is from the 2023 finals, and the 2024 finals has been out for a couple months too. So go check that out. Please notice me, guys. But yeah, if you guys are interested in maths, science, technology, anything educational at all, just hit that follow button. Much appreciated. Thank you so much.